So in this problem we want to solve Laplace's equation inside the unit disk when we're given the boundary condition that's on the upper half of the disk. The boundary of the upper half we've got v equals v0, and below it we've got v equals 0. Okay, so we use the transformation w equals I times 1 minus z over 1 plus z to take us to the w plane, and 1 gets mapped to 0, and so everything, so basically this region here gets mapped to here. So we've got v equals v0 here, and we've got v equals 0 here. So in this system we've got del squared v tilde equals 0, if you like. I write it as v tilde since it's a function of u and v at the moment. Okay, so this is now straightforward to solve, just using this again. So we've got v tilde as a function of u and v is equal to v naught plus 1 over I, and we've got naught minus v naught. Okay. And it's w minus 0, so it's u plus iv. Well, I'll keep it actually as w, because I'm going to immediately then rewrite w as using this. So I get u naught minus 1 over I argument of I times 1 minus so I use the trick of multiplying top and bottom by the conjugate of this. So I've got 1 minus x minus iy times 1 plus x minus iy. So that's going to give me okay, so I'm multiplying everything by I, so I'll do the imaginary part of this first. So the imaginary part, what am I going to get? I'm going to get minus iy times x minus x, and I've got a minus iy times the plus x, so that's going to cancel. So the bit which won't cancel is when I do the minus iy times the 1, and I've got that twice. So that gives me 2 minus iy, and I've got times I, so that minus I times I is plus I, so I get 2y as the real part, and then the imaginary part, which is the I times the real part of this, so that's going to be 1 minus x times 1 plus x, which is 1 minus x squared, and then I've also got this times this, which is going to give me minus y squared, so I'll end up with this. And finally, I can use the trick that this is, I can take out a factor of pi, and this is then pi minus arg of this, which is the same as the argument with this change to a minus sign. So I've got minus 2y plus 1 minus x squared minus y squared times I. I forgot to switch this round. This should now be v of x, y. Now I've changed everything to x and y. So v of x and y is equal to this is our final answer.